You guys know how to prove triangles congruent, right? There's 5 methods. What's it mean? Let's quick review. What's it mean for 2 triangles to be congruent? Before you guys came in, I did a nice little diagram for you. If 2 triangles are congruent, all the corresponding sides are congruent, and all the corresponding angles are congruent. When we start talking about similar triangles today, not the case. Not the case. The only thing that's true, that was true for congruent triangles, is that corresponding angles are still congruent to each other. Okay? Corresponding angles in 2 similar triangles are still congruent to each other. So let's set this up real quick. So if I go triangle ABC here, and triangle ZXY, corresponding angles are still going to be congruent. Okay? So congruent, congruent. Here's the change from similar to congruent. Here's the change. The corresponding sides do not have to be congruent, but they have to be proportional. What do I mean by that? Here you go. Let me set you up a pair of some sides. This side's a length of 2. That side's a length of 6. 3 and 9 for here. And the other 2 sides, 4 and 12. Do you see the sides obviously aren't congruent? Everyone's in agreement with me. The sides aren't congruent, but they are in the same proportion. Does everyone see that? I'm not going to ask what the proportion is. I'll get to that in a second. But does everyone see that corresponding sides are all in the same ratio or proportion we talked about on Friday? All good. Okay, just like congruent, I want you to write a statement, similarity statement now. Okay, so I'll start it off. Triangle ABC. We come to our first maybe question of the day. What is the sign for similar? Anybody know? Let me tell you, it was part of the congruent symbol. Take away the equal sign. Remember what was left? Don't say it. Don't. It's embarrassed. Don't say squiggle. Okay, don't say squiggle. Yes?
The worm.
Worm. Ugh. Anybody know its official name? And I never knew this until about 3 years ago. Some student told me. Tilde. It's a tilde. Okay, there you go. All right. The squiggle. All right. Just like congruent, make sure the sides and angles match up. Okay, that's still going to be the same. All right, just when you wrote your congruent statements, you matched up corresponding sides and angles. Same thing when you write a similarity statement for me. Match up the corresponding sides and angles. So if I have triangle ABC, what would I have over here? Triangle ZXY. Yep. Remember I said they had corresponding sides were in the same proportion or ratio? That's called the similarity ratio or scale factor. No both. All right, no both. Scale factor or similarity ratio. So if I'm going from triangle ABC to triangle ZXY, what's my similarity ratio? Pick any pair of corresponding sides. Ready? 2 to 6. You could write 4 to 12, 3 to 9, or any of the reduced version. Anything would be acceptable. All right? So we could go 2 to 4. Or we talked about, remember the other way to write it from Friday. I could go 1 to 2. And what am I doing? Sorry, 2 to 6, excuse me. Surprised none of you jumped all down my throat on that one. 2 to 6. We could also write it 1 to 3. You could also go 4 to 12. All right, any of these are acceptable. So anytime we're looking for the scale factor, similarity ratio, that's the ratio of 2 corresponding sides. All right. All good. Questions? Hey, when we talked about congruent triangles, how many methods were there? Congruent triangles, how many methods? 5. Some of you thought there were more, but only 5. Similarity? 3. 3 methods of proving triangles similar. Similar. All right, so let's talk. First one, some of you should be happy to hear this one. Angle, angle. First way of proving triangles similar is angle, angle. If you have 2 pairs of congruent angles, The triangles are similar. Well, why doesn't the third pair have to be congruent? Why don't they call it angle, angle, angle? Anybody know why we don't call it angle, angle, angle? Why we stop at 2 A's instead of 3? What's up, Matt? The third have to be congruent. Remember third angles theorem? We don't need the third A there. Okay, it's just angle, angle. All right. Do I care if you have the little tilde next to it? For this one, no. You can put there if you want. All right, angle, angle, tilde, but angle, angle's fine. Everyone understand angle, angle? Two triangles are similar by angle, angle. All right. Here, I gave you two triangles here. Why are they similar? Why are they similar? Well, what did I give you right off the bat? What did I give you about angle H and angle S? They're congruent, right? They're both 45. And do you see anything you can mark on your own? Anybody see anything you can mark on your own on those two diagrams? Two triangles. Here we go. Oh, we're on fire. Nothing yet. All right, what do you got for me? We're the verts, right? UOH and SOE are congruent. So does everyone see these triangles are similar by angle, angle? Write the statement for me now. Write a similarity statement. Triangle. Anybody want to share theirs? Because this is how I'm going to get calling on people now. Go ahead, let's go. Nate, go ahead. UOH, similar. Whoa, whoa, whoa! How many of you put the congruent symbol? Check yourself. That's a huge, I guess you call it a mistake, all right, that you rookies fall into. You're so used to putting congruent, congruent, congruent. Similar to what? UOH and EO. How do you do? E and U, H to S. Not bad, right? And we'll just put by, get started getting used to this, angle, angle. Thanks, Nate. I'm going to need you in a second to call on somebody for me. There is one method. Method number 2. Ooh, this looks familiar. Side angle side, but now we're going to put it side angle side similarity. Ready? Hey, one pair of angles, but the sides surrounding them don't need to be congruent, but they need to be in the same proportion or ratio. Okay, they don't need to be congruent. They need to be in the same proportion or ratio. Watch, ready? Here we go. I'll just show you here. Everyone sees R and S are congruent. Are those sides in the same ratio? All right, well, you tell me. Is 10 over... Now, there's a lot of ways to write this ratio. Do you guys tell me what you want me to do. Do you want me to match it up with its corresponding side or just put both sides from the same triangle in one ratio? Match it up or put it from the same triangle? Which one do we prefer here in this class? Because usually I get yelled at every year the way I do it. You want me to match it up? Well, that's a first. Everyone always yells at me for doing that. That's what I do. So what would the 10 match up with then? The 10 would match up with the, okay, is 10 over 15 the same as 12 over, what would the 12 match up with then? 18, all right, well, let's see. How do you figure out if they're the same? Multiple ways here. How do you figure out if they're the same? Nate, need somebody. How am I going to figure out if those two fractions are the same? Okay, let's simplify them then. Let's see, 10 over 15 is going to be 2/3, right? And how about 12 over 18? 2/3? Your calculator does it as well, so yep. Anybody know a different way other than simplifying? Nate? You can cross multiply. That's a big way. Cross multiply and see if you get the same answer. So is 10 times 18 equal to 12 times 15? All right. All right, here you go. Two right triangles. Explain why they're similar. Well, it looks like side angle side, right? You got the two right angles congruent. Now, are these in the same ratio? Jack, need somebody. Let's go. Matt, you want to set up a proportion to check to see if the sides are in the same proportion or ratio? 8 corresponds with 6. Is that the same ratio as 4/3? I'm going to take Nate's suggestion and cross multiply. Let's see, 24 equals 24. Got it. They are in the same ratio. And is that right angle? And I know this is simple stuff now at this point in the year, but is that right angle in between them? Yes, it is. So triangle so-and-so, similar to triangle so-and-so. I'm going to ask somebody. Matt, who's going to give it to me?
Triangle PAC is similar to EDF.
Bye. Everyone ready? Now, hey, everyone, focus in. Remember angle, I didn't have you put the tilde with it, but now I am. I'm requiring you to do that. Anybody know why? I'm not trying to be a stickler or cranky about it. Anybody know why I'm having you put the tilde with side, angle, side? Go ahead, Evan. For congruence, absolutely. If you just write side, angle, side, I'm kind of thinking that's for congruent triangles. All right, so by putting the tilde there, it's for similar. Angle, side, angle, side. Ready for the last one? Another familiar one to you guys. Side, side, side. All 3 sides are in the same proportion. All right, all 3 corresponding pairs of sides are in the same ratio. Now, a lot of people always say, how do you know which one matches up with which? Great question. Ready for the answer? Very simple. Smallest side with smallest side. Largest side with largest side. Okay? Up here, Andrew, need somebody. Here we go. What would the 5 match up with? What would the 8 match up with? And how about the 13? There you go. We called that an extended proportion on Friday. 3 or more. And I guess here, I love Nate's response about cross multiplying. But if you did that, you'd literally have to do this one. Every combination of ratios, cross multiply them and see if they came out to be the same. So probably when you have the extended proportion, the best way is just to simplify it. All right. So everyone good on the 3 methods? All right, I'm only going to do these 3 with you, and then I'll let you go on your own. Are the triangles similar? If they are, back yourselves up with one of the 3 reasons we've just discussed. Who's up? What's up, Nate? I'm sorry to hear that. You got everything you need, so you can take it. Go ahead. I believe you, unless you're making bootleg passes up at home. Kid's got a printing press in his basement, selling them on the black market. Jack, need somebody there, stud. Ready, Evan? Are these 2 triangles? I got a pair of congruent angles. Got anything else? Look at this kid using the language and the street lingo now, the verts. So are they congruent? Are these 2 triangles similar? They are? Got a statement for me.
Triangle X is similar to triangle RQX by angle.
Check your papers. You don't have to tell me, but how many of you just put the congruent symbol again? You're better than that. You're better than that. Thanks, Evan. Who's up now, Evan? Need a stud here. Math stud. Okay, here we go. I'm looking at this and everyone else too. I'm just not Ethan yet here. I'm thinking this could be side angle side or it could be side side side. Everyone agree? Okay, so you could test out either one here. I don't care where you want to go here, Ethan. How do you want to set up the ratios of corresponding sides? Okay, so is 9/12 the same ratio as 12/16? All right, we could stop there because you gave me the sides that surround the right angle, so we could stop there. So is this proportion equal to each other? You could reduce or cross multiply. You let me know. Nine over 12, the same as 12/16. Yes, it is. I believe you get 144 on both when you cross multiply. So these are similar. So now I need a similarity statement from you there, Ethan. Hold on, PXM similar. Everyone's similar. WLA. By what method?
Side angle side.
Yep, and just make sure we go side angle side similarity. Good. Not bad, Ethan. All right, need somebody else here, another stud. Okay, you ready? The only method it could be out of the three would be what? Side angle side. That's the only method it could be because he sees the vertical angles right here. Now I just got to check if they're in the same proportion. Now, when I say same ratio, couldn't the 3 match up with the 4 depending on how I turn them? And the 3 also could match up with the 8. So I have to actually check out every single possibility here. Okay, because depending on how I turn this, the 3 could match up with the 8 or it could match up with the 4. So we're going to set up 2 different proportions and see if any of them are equal. Good deal? Okay, so how do you want to start? 3 match. So you're going to say this 3 matches up with that 4 and 4 to 8. Those equal. Okay? But also, the 3 could not just match up with that 4. It could match up with the 8. And then what would this 4 match up with? The other 4 in the other triangle. Are these 2 equal? Nope. So what do we know about the triangles? Not similar. Everyone see that? That I had to test both ratios depending on how I turned it. So not similar. How are we picking this up, all right? Not bad? I guess I should do a couple of these with you right now. This might be my, I'd say top 8 word problem of the year. Right here. Read through it. You'll see why it's in top 8. Natasha. She's going to place a mirror on the ground. That's 24 feet away, not from any tree, but an oak tree. So let's just all absorb what's happening right now. We have this random girl, Natasha, who decides just to place a mirror on the ground, a mirror, from an oak tree. Pretend you're just walking in the park and you see Natasha doing this and your reaction. She's going to walk backwards until she can see the top of the tree in the middle of the mirror. At that point, Natasha's eyes are 5.5 feet above the ground and her feet are 4 feet from the mirror. What's the height of the tree? How many of you are going to go over to the town park later and throw the mirror on the ground and try to be Natasha? Don't let me catch you because I will just go off on you. You'll never live it down. All right, so I guess we have to answer how tall is the tree. All right, we got 2 triangles there. Now we are using the fact that similar triangles mean what about the sides? The sides are in the same ratio, right? So give me 2 corresponding sides right now. 2 corresponding sides. Who was the last one up? Frank, need somebody. 4 and 24 match up, Ethan. Thanks, and so do. Okay. Natasha. And what do you got, Ethan? No, for Natasha's age, grade. What's that? Desk, oranges, corn shackles. 33.
Oh yeah.
Thank you. If the question has feet, everybody, so should your answer. What are corn shackles? Don't worry about it. All right, ready to roll on this next one. Who's up, Ethan? This one's a tough one, by the way. Ready here, superstar? Do you see the 2 triangles? Yeah. All right. In case your classmates don't, here we go. Give me just one side of one triangle right now. Oh, you went okay. All right, you're going big timer on me. So he's taking the large triangle. He's saying one side is 25. What would that match up with in the small triangle now? 20. Good. Well, 20. Where do you get 20 from?
Oh, in the small triangle?
Yeah. Because that's how you could do it that way, the way you're doing it. I'm just doing it the way we've been doing it all class here. So the 25, this side would match up with what in the smaller triangle now? You're right. Yeah, be confident. Why? You're fine. Okay, give me another side, probably X, right, in the larger one. And what's that correspond with in the smaller one? Okay. Everyone, are we clear that there are multiple ways I could set this up? This is not the only way that Justin just gave me. Multiple ways of setting this up. All right, so go ahead, X equals, and yes, you are going to get a decimal here. Don't freak out. Let me know when you get there, Justin. Yep, so I'm just going to write 28 1/3. Okay, everyone, hey, focus in. Pencils, calculators down. Don't move on to the next one. Just put them down here. And I'm surprised no one's asked this yet in this class. I can't set them